This is the third lesson in our in Unit 2. We're going to talk about acceleration. Now, acceleration will be what we spend most of the entire unit on from here on out, but this part of it is review, and after we do velocity time graphs, we're going to get into all kinds of new equations and new types of problems involving both gravity and regular acceleration in types environments. So in general, acceleration is the rate of change of velocity. So it's a change in velocity over time. And if we've forgotten, but units are meters per second squared. Symbol is a with a vector, and our equation, as we know it right now, is change in v over time. Now, one thing I want to point out about the units is it could be written in this way, meters per second, or meters second to the minus 2. They're all equivalent, and if you don't agree with me, we can go through it mathematically, but they are all equivalent, and you might see each of those, particularly the second one there, depending on where you're looking for some extra information. So a car traveling at 30 meters per second applies its brakes for 1.2 seconds and is traveling at 22.8 meters per second. Find the acceleration. Let's model, good problem-solving techniques. Let's start with what we know, come up with our equation, and plug things in. It just helps us organizing our thoughts. So as we're reading it across, a car is traveling, so V naught is 30 meters per second. Time is 1.2 seconds, and then it is traveling, so V is 22.8 meters per second. And what is the acceleration? So, just as our equation is, acceleration is our change in velocity over time. Now, for a question like this, where we don't have a north, south, east, west, up, down, left, right type directions, the vector arrows, once you put your numbers in, aren't necessary, because it's not a true vector in terms of having an actual direction. So let's plug things in. We know delta V is our V minus V naught, so we have 22.8 meters per second minus 30 meters per second, all over 1.2 seconds. Now I'm going to do this in one extra step here because I want to show the 22.8 minus 30 so that we can keep track of our sig figs properly. So when you put this in your calculator, 22.8 over 30 minus 30 gives you negative 7.2, and that's that's meters per second, all over 1.2 seconds. And you calculate that out, and we're going to get, your calculator will give you minus 6 meters per second squared as our acceleration. Now, for proper sig figs, we need to make sure we're using both rules because we do a subtraction and then division. So for the first part, we did 22.8 minus 30. And so addition subtraction rule is to the decimal places. So our answer there, the sig fig should go to 7 because it's the 30 is precise to we'll say that it's 30. We can think of it as 3.0 times 10 to the 1. I don't like going to one sig fig very often. I'll be sure to avoid that in tests or assignments or those types of things. So if we're going to the ones column, so our final answer here, this would be 1 sig fig is our goal. And so 1 sig fig over 2 for multiplication division. Our answer has 1, so we end up with a final answer of 6. Let's take a look at the next example and see and work that through, and also keep in mind our sig figs rules for this. So how long does it take a car traveling 25 meters per second to slow down to 5 meters per second if the acceleration is negative 8 meters per square? Don't forget that negative over there. It got, just jumped to the next line, which is kind of unfortunate. So we are traveling, so V naught is 25 meters per second. V, our final, is 5 meters per second. And acceleration is 8 meters per second squared. And we're looking for time. Start with our original equation. Change in V over time. We can drop our vectors because we're not dealing with north, south, east, west, up, down, left, right, as so on and so forth. So we got to rearrange this equation. I'm going to do it in 2 steps. We have to multiply by time first, and then we're going to divide by acceleration. And so now we're just going to plug things in. Delta V, so V minus V naught, we have 5 meters per second minus 25 meters per second, all over 8 meters per second squared, and that is negative. Mathematically, we should get 2.5 seconds out of our calculator. Now sig figs, let's take a look at them. So at the top, 5 meters per second minus 25 meters per second, to addition subtraction, that's going to give us to a number to the of negative 20. Negative 20 is accurate to the ones place, but we're dividing by negative 8, which is only 1 sig fig, so we have to round our answer to 1 sig fig, so time has to get rounded. So 2.5, our 5 rule here actually comes into play for one of the first times ever, and we're going to round to the even number, so 2 seconds is our proper sig figs. Okay, let's start this next one and we'll continue it in class, and we can go over some workbook problems in class as well. So if it takes 3.5 seconds, so let's write that out, 3.5 seconds. Final velocity, so that's V, is 18 meters per second at an acceleration of 2 meters per second squared. What was my initial velocity in meters per second and kilometers an hour? So there's 2 answers to this problem, so we'll have to do a conversion, but we're looking for V naught. So you've got to start with our original equation. We're going to have to rearrange it for initial, so V naughts. So I'll leave that and we'll take that up in class.